So when you have, I just pulled 2 of these. If you have something like 1 and 2, you're going to square both sides, and really it's going to get rid of your radical and possibly square a number. If you have things like this, you're going to have to end up foiling. So your goal for something like number 5 would be to move that x over. So it's a minus x, so I would add the x over. I have x plus 1 over here, and I have my square root by itself on this side. So when at this point, you can just square both sides. You wouldn't want to do it ahead of time because it would make it more difficult on the top piece of it. I will say the biggest mistake people make here is not foiling that left-hand side. Remember, that is x plus 1 times x plus 1. So you do end up with x squared plus 2x plus 1. And then on the right-hand side, your radical just goes away. This is a quadratic, so by that I mean I have a squared, x squared. So when you have an x squared, you want to move everything to one side and set it equal to 0. So you can possibly either factor or do the quadratic formula. So I'm going to move that 4x and that 4 over. I'll have x squared minus 2x minus 3 equals 0. This is factorable, x minus 3, x plus 1. My answers are 3 and negative 1. You do need to check and make sure they both work, because if you'll notice, the instructions say to check for extraneous solutions, which means it's possible you could plug that in and it not work. In this case, actually, both of those work. So you have 2 answers here, x equals 3 and x equals negative 1. I mean, it's possible that neither could work really when you do these. So you do need to check for extraneous solutions and make sure they both work. For something like number 7, you really can't get both of these by themselves. So you do have to get at least one of them by themselves. In this case, your negative 5 minus 5b radical is already by itself. So I would just leave this alone and go ahead and square both sides. Now, when I say square both sides, again, you have a plus or minus on the right-hand side here. So you do need to FOIL that right-hand side when you square it. The left is just going to be the negative 5 minus 5b, but this is going to FOIL. So you're going to end up squaring that first one, that's 4, multiply and doubling it, so 4 square root of negative 3 minus 2b. And then, of course, when you square this last one, it just gets rid of your radical there. Again, you're trying to get that radical now by itself. So you can combine these guys. You're going to get a positive 1. So you would subtract that 1 from both sides. You have this 2b. So you're going to add that to both sides. So you have a negative 6 minus 3b. Right? And now you can square both sides. If you had something where you could take something out, like say that was a 6, a 3, and a 3, not a 4, you can divide out a 3 out of everything, potentially do that. Or if you could divide a 2 out of everything, divide that out, make your numbers smaller. If you can't, then you're just going to have to FOIL or square both sides. On that right-hand side, when you square it, you do need to square that 4. Right, so you do need to worry about that coefficient there. On the left-hand side, you're going to have to FOIL. So when you square both sides, you're going to end up with, I will try to make sure you don't have ginormous numbers on your test, but negative 6 and negative 3, and then double it. And then you're going to square this one. On this side, you're going to have 16 times this group. At this point, you're literally just solving a quadratic. So you can distribute here. I would put this in standard form once I'm done. So negative 48 minus what, 32b. So we're going to add this. We're going to add this. That will zero out here. And then I would put it in standard form, b squared plus, oh my goodness, they love these huge numbers, right? What is this, 94? Oh, that's 84, not 94. When I have something like this, even if it's factorable, right? You have 84 and 9 to worry about. I wouldn't factor this. Just go straight to the quadratic formula. You have a calculator, plug it in, negative b plus or minus the square root of b squared minus 4ac over 2a. Let's just do your quadratic formula there. Yeah, I would not do factoring here, okay? So it actually works out to like -6, by the way, when you do your quadratic formula, which means you're probably going to get 2 answers for quadratic and one's not going to work. Just so you know, x is going to equal -6 here when you go into quadratic formula. You'll get 2 answers. One won't work. So for polynomial, you'll see that there are multiple things listed here. State the maximum number of terms, determine the real zeros and state the multiplicity, list the intercepts where it crosses and where it does not cross, and describe the end behavior, and then you will sketch the graph. So you could have some that end up factoring, or you could have some that you have to use your synthetic division with your possible zeros, right? So make sure you understand either of those concepts. I think 11 is one where it's not going to factor. You can take an x out, but you're going to have to use like 1 and -1 and try to figure out what your zeros are. This one is going to end up factoring. So the first thing is maximum number of terms. That requires no math whatsoever other than subtracting a 1. So maximum number of terms is just your degree minus 1. In this case, your degree is 3. So your maximum number of terms will be 2. That's an easy answer there. Determine the real zeros. To determine the real zeros, you will want to start out by trying to factor it. So in this case, I'm going to take an x out. I'm left with x squared minus 6x plus 9. So I have an x, and of course, factors of 9 that add up to 6. You're going to have x minus 3, x minus 3. It says to state the multiplicity. So my zeros would be what makes this 0. Well, if you pull an x out, automatically 0 is going to be one of your answers. And then whatever makes these 0. Well, both of those get to be 0 by a 3. So that means you have a 3 and a 3, which means you have a multiplicity of 2 here. Because 3 is repeated, okay? So then that walks you right into number 3, which is which ones cross and which ones don't, okay? And so zeros that cross are going to be the ones with an odd multiplicity, a 1, a 3, a 5, right? So 0 only happens one time, so it is going to cross at x equals 0. It doesn't cross, or it bounces at 3, because 3 has a multiplicity of 2, 3, 3, right? So we're going to say at x equals 3, it does not cross. And that's going to actually help us figure out what's going on, right? Describe the end behavior. End behavior is based on my degree and my leading coefficient. That's your little shortcuts there. Odd, they're going to go different directions. Even, they're going to go the same direction, right? And then you look at your leading coefficient. If it's positive, it's going to be going up from left to right. Or if it's the same, they're both going to be going up. If it's negative, it's going to be going down from left to right, or down on both sides if it's even, okay? So in this case, it's odd, which means it's going to be going opposite directions. But it's positive, so it's going to follow what you think it would follow. So the limit as x approaches negative infinity, or the left side of the graph, will go down. And then the limit as x approaches positive infinity, or the right side of the graph, will go up, positive. All right, so when it's odd degree, it's going to go opposite directions. One's going to go to positive infinity, one is going to go to negative infinity. If it's a positive leading coefficient, they'll follow. As x goes to negative, y goes to negative. As x goes to positive, y goes to positive. So that starts to give us a little picture of this graph here. The first thing you really want to do is you want to plot these real zeros. So I have a real 0 at 0. I have a real 0 at positive 3. All right? And then you want to say, does it cross or bounce? Well, it's going to cross at 0. It's going to bounce at 3. That's what we just determined. I know that on the left-hand side, I'm going to negative infinity because of my end behavior. And I know on the right-hand side, I'm going to positive infinity. So I'm going to be coming from negative infinity when I get to that 0. Somewhere up here, I'm going to have to turn. I'm going to bounce off at 3, and then I'm going to go back up to positive infinity. I do not require you to divide a certain way. I will say that if you do synthetic with something like 15, you're going to have to divide out that 4. Everything except your remainder is going to be divided by 4, right? So once you do, if you were to do 3/4, your final answer, everything needs to be divided by that 4 except your remainder, okay? But you're welcome to if you like fractions and you want to do it that way. For both ways, whether it is synthetic or if it is long division, you must have a placeholder for every single exponent from your degree down. So by that I mean for this guy right here, we have x squared x. We need a 0 for our constant place. For this one, it's 4, 3, 2, 1 constant. This guy's good to go, okay? So just make sure that you remember whether it's long division or synthetic, you must have a placeholder for every exponent from your degree down. All right, so I typically would say 14 would be easiest to do synthetic, 15 would be easiest to do long division because most people don't want to deal with fractions. For synthetic, you're just using your coefficients. My coefficient here is 1. My coefficient here is -3. I do not have a constant, so I'm going to put a 0 here. On the outside, I'm going to do whatever makes this guy equal to 0. Well, what makes it equal to 0 is a +1, so I'm going to put a +1 there. And then I'm just going to do my synthetic. Remember, you add down. Common mistake here is that you have positives and negatives and you end up subtracting down, okay? So add down, 1 plus nothing is 1. Multiply up, 1 times 1 is 1. Add down, -3 plus 1 is -2. Multiply up, -2, add down, -2. All right, at this point, you're actually finished. You just need to rewrite it with your variables. You're going to go down 1 from where you started. I started at x squared, so it's going to be 1 times just x to the first power, -2, that's my constant. This last number here is my remainder, so -2 over x minus 1. And so this would be my answer for this guy right here. All right. For this next one, you likely will do long division. Some of you won't, but that's up to you. This one, you leave everything the way it is. 4x squared minus 23x cubed minus 21x squared plus 15x plus 5. Divide by what is out here. You only have to look at the first one when determining 4 times what equals 4x to the 4th. So we would say just x cubed and then distribute. And remember, you are subtracting, so you are adding the opposite. Again, the number one problem here are your positives and negatives. And you're going to do that all the way down. Bring down what you have here. What do I have to multiply to get this next one here? You're going to say, well, 4 times -5 gives me 20. And then I need 2 x's there. And again, you are adding the opposite. So you end up with a -21 and a -15. Again, this isn't hard, it's just a lot of room for error. And so you want to make sure that you're paying attention to your positives and negatives here. Any questions on long division or synthetic? Your final answer for long division also needs to be in with a remainder over your original. So this is your final answer here. So evaluate, when you see the word evaluate using synthetic substitution, you are going to use synthetic division, all right? Just like the other time that you use synthetic division, you have to make sure you have a placeholder for everything. 6, negative 19, positive 14, and a 0 because you don't have a constant. When they give it to you with synthetic substitution, you do not do the opposite. They said k equals 3. You're going to use just 3. But hear me, because this is where people lose points. For synthetic substitution, your answer is your remainder. You don't put it back with x's. You just get that remainder, and this guy is your answer. So you're going to do the synthetic division the same, but your answer is only your remainder. Do not go back and put your x's in there and give me the whole polynomial, or you will lose points. So synthetic substitution, your answer is just your remainder, all right? To tell me if it is a factor, you can use synthetic or long division. Synthetic or long division. Your answer, though, is yes, it's a factor, or no, it's a factor. If your remainder equals 0, then yes, it is a factor. If your remainder does not equal 0, then no, it is not a factor. But your division will be the same. Synthetic or long division, you can do either. What you're doing is you are just looking at your remainder here and saying yes or no, is it a factor? So this says state the possible number of positive and negative zeros. That's Descartes rules of signs. The possible rational zeros, that's where you take your factors of your last one over the factors of the first one. Then find all of your zeros, and you notice in the instructions it says 1 0 has been given, okay? 1 0 has been given. So, positive and negative zeros. So, the possible number of positive, that's where I am going to compare the sign changes. This is a positive 2 to a positive 3. Did not change. Positive 3 to a negative 9. That changed, so I'm going to count that one. 1. Positive 9 to a positive x. That changed. I'm going to count that one. All right. And then a positive to a positive did not change, so I am not going to count that one. So I counted 2 positives. But remember, it's 2 or anything down from it in 2s. So if it's 2, it could be 2 or 0. I could have 2 positives or no positives. It always goes down by 2. If it had been 7, you would say 7, 5, 3, 1, right? It always goes down by 2s until you get to none, all right? For the negative, I am going to do the same thing, but I'm going to consider what would happen if I plugged in a negative x. All right, so for my negatives, I'm going to do the same thing. But I'm going to say, what happens if I plug in a negative? If I plug in a negative to this first one, it's to the 4th power. It doesn't change anything because it would be a positive. If I plug a negative into this, it's to the 3rd power, so it actually changed this sign. If I plug a negative in and square it, it will not change anything. If I plug a negative in here, it would change it. And 3 does not have anything to plug into. So obviously the constant will never change. And then I'm going to go back and recount. Now this one goes from a positive to a negative. I'm going to count that one. Negative to a negative did not change. Negative to a negative did not change. Negative to a positive, I'm going to count that one. That's also 2, which means it's 2 or 0. To find your possible zeros, you're going to take your constant factors over your leading coefficient factors, all right? So my possible rational zeros is going to be a list of numbers. My constant is a 3. It only has 2 factors, 1 and 3. My leading coefficient is 2. That only has 2 factors as well, 1 and 2, okay? So I'm going to put these factors over these factors and consider the positive and negative. So I have positive and negative 1 over 1. Well, that's just 1. Positive and negative 3 over 1. That is just 3. Positive and negative 1 over 2. That's 1/2. And positive and a negative 3 over 2. Those are all my possible rational zeros. Now, obviously, I won't have all of those because I can only have 4 zeros at most because my degree is 4, okay? But those are my possibilities. Those are my possibilities. The last step says find all your zeros. I've already given you 1. All right? So zeros, that's my last one. They gave me 1, so go ahead and list him. You know that he is a 0. They told you that. -3 is a 0. Go ahead and put it down. All right? That's one of your zeros. Then you're going to take that -3 and I would do synthetic division here because they already told you a 0. So we're going to do synthetic division. We have a 2, a 3 coefficient, a -9, a 1, and a 3. All right? If you don't get a 0 as your remainder, you did something wrong in your synthetic division because they told you -3 was a 0, okay? So you're going to do your synthetic division, add down, multiply up. So if your remainder is not a 0 here, you've done something wrong, okay? So now I have this, which is going to be an x cubed. X cubed minus 3x plus 1. That's not factorable, by the way. Not with that x cubed in there, right? And we can't take an x out. So I'm going to go ahead and do synthetic division with 1 and -1. Because I know 1 or -1 could be a 0. So I'm going to see if it is. You don't have to start at the beginning. You can actually start at this next level if it was a 0. You can just go down from here, okay? So you can add the 2 down, multiply up, add down, multiply up, add down, multiply up, and we have a 0. So now I know that 1 is also a 0. So I'm going to add +1 up here, all right? And now, so I have gone a level down. This was going to be x cubed x. So this one is going to be x squared x. So I have 2x squared minus x minus 1. This guy is factorable, all right? So you can multiply across, or you know that you have 2x and 1x. I need my 2 to be negative, so that's -1. +1, it is factorable, all right? So once it's factorable, factor it and set it equal to 0. Or let's say you don't know how to factor this, use the quadratic formula. You're gonna get your zeros once you have a quadratic, okay? Once you have a quadratic, x squared, you can either factor it. If you're no good at factoring, make sure you know that quadratic formula forwards and backwards. Because either way, whether it is rational or irrational, you will be able to find your zeros at this point with your quadratic formula. Once you have these guys, set them equal to 0. We have 2x plus 1 equals 0. That's going to give us a -1/2. And x minus 1 equals 0 is going to give us x equals 1, which we already have. So you can say multiplicity of 2 for +1 because we already have a +1 up there. So let's talk through these. Holes, x and y intercepts, vertical asymptotes, horizontal or slant asymptotes, sketch the graph. So really, a lot of these things come from factoring this guy. And so you want to kind of do two things. You want to have him unfactored because you will look at your horizontal with it unfactored, but you also want to factor it. So factor the numerator, x plus 2, x minus 1. Factor the denominator, you can take an 2x out, you get x plus 3. All right, and then we're just gonna go through this list. We have, the first thing it asks for is any holes. All right, holes, that is the denominator equals 0 and it cancels. Denominator equals 0 and it cancels. Well, I have two places where my denominator equals 0. It equals 0 at this guy, which is actually 0, and it equals here, which is negative 3. The thing is, neither one of those cancel with what's on top. So I don't have any denominators that are 0 that cancel, which means I do not have any holes. So for this one, my holes would be none. All right. The next thing it asks for is x and y intercepts. So x-intercept. X-intercept is where my numerator equals 0, but does not cancel. Does not cancel. If it had canceled, it would have been a hole, okay? But if it doesn't cancel, it's going to be an x-intercept, all right? I'm going to have two possibilities here. Negative 2 makes the numerator 0, and positive 1 makes the numerator 0, and neither one of those canceled. So my x-intercepts are going to happen at positive 1 and negative 2. Those are my x-intercepts. Y-intercepts. Y-intercepts happen when I plug 0 into everything. So plug 0 in for x. In this case, I have 0 squared plus 0 minus 2 on top, and I have 0 plus 0 on bottom. We have a problem. If I plug in a 0, I get a 0 on the bottom. So I do not have any y-intercepts here at all right? No y-intercepts at all. Had there been like a plus 3 on bottom, I would have had negative 2 over 3, okay? But the plugging in a 0 caused an issue, so I do not have any y-intercepts here. All right, the next thing it asks for is vertical asymptotes. Now, vertical is where my denominator equals 0, but does not cancel. So holes is where it canceled. Vertical is where it does not cancel. So once again, right here, 2x. What makes 2x 0? Well, 0 makes 2x 0, and it did not cancel. What makes x plus 3 0? Well, negative 3. And that one also did not cancel. So I actually have two vertical asymptotes here. And the last thing it asks for is horizontal or slant. All right? I will not have both. I will have one or the other. All right? So my shortcuts here for this guy. For horizontal, if we're talking about degrees here. If the degree on the bottom denominator is larger than the numerator, my horizontal is y equals 0. If my denominator equals my numerator, we're talking about degree, then it is my coefficient on top over my coefficient on bottom. It's a fraction. If my numerator is larger than my denominator, I have a slant. I have a slant, and I have to divide and figure out that linear piece that is my slant. All right? In this case, my degree and on the numerator and the denominator is the same. So you'll notice that I have x squared over 2x squared. That's the same degree, which means I'm going to use that 1 on the top over the 2 on the bottom. So my horizontal is y equals 1/2. And once I have all of that, I am actually going to start sketching my graph. All right? If I had holes, I would actually worry about those later. I can go ahead and plot these x-intercepts. All right? I have a +1 and a -2. All right? I can go ahead and graph my vertical asymptote here. All right? It's just a vertical line that's dashed at those two places for x. So I'm going to do that at 0, which is just my y-axis, which is why I don't have a y-intercept, by the way. And it's also at -3. So I'm going to come over here to -3, and I'm going to graph that one. All right. I have a horizontal, so I'm going to go to 1/2, and I am going to do a horizontal asymptote. All right. Now, how do I graph it? Well, over here, if I were on bottom, I would have to cross the x-axis. Do I have an x-intercept over here? I don't. So the only place this guy can be is up here on the top. All right, here I have an x-intercept that I have to cross. I have to cross it. And so I know that I'm going to have to cross it. You can test a point to see which side of it is negative and which side is positive, right? But I know I'm going to have to cross it. And so if you test it, it's either going to go up or down through it. It's not going to bounce off like a parabola or anything because it's a multiplicity of 1 there. If I look over here, I have to be down here because I have an x-intercept, right? And so I know that I'm going to have to be on this side of this guy because of that little x-intercept. So he's going to have to do something like that. I cannot be on top and bottom or it would not be a function. It would not pass the vertical line test. One or the other. It can't be on top and bottom. Goal of a rational equation, really quickly, is to get rid of your denominators. Find your lowest common denominator and multiply by it. Whether it's something big like that one or whether it's something like this one. All right, so least common denominator is what you're looking for in these. When you have something like this first guy, you have an m squared and an m. So your least common denominator is just going to be that m squared, whatever to the highest degree that it is. So then when you multiply everything by that m squared, right, you're going to cancel it here. You just have the 5m minus 5. One of the m's will cancel here, so you have 1 times m. And then both of the m squareds cancel there. And then you have something rather simple to solve, right? Subtract your m. You have 4m. Add your 5 over. All right, so then we have a 2. Divide by your 4, m equals 1/2. All you have to do is make sure it doesn't cause a problem in your denominator. The only thing that was excluded was 0. 0 is your only excluded value there. So the next one's a little more difficult, but if I were to factor these, you would see that you get p minus 2, p minus 5 as my factor, right? And so the least common denominator is this whole thing, p minus 2, because that includes this one, and p minus 5. Now what happens when I multiply each of these by that LCD, that least common denominator, this entire thing will cancel because that was my entire. This entire thing will cancel, right? And then for the 3, just the p minus 2 is going to cancel. So what happens there is I am just going to be multiplying by what didn't cancel, the p minus 5. Okay? So I have 3 times p minus 5 plus this whole thing canceled. So I just have the 1 equals this whole thing canceled. I just have the 4. Right? And then I'm going to just solve, distribute 3p minus 15 plus 1 equals 4. I have 3p minus 14 equals 4. Oh, why'd he go away? Then I have, add my 14 over. I get 3p equals 18, p equals 6. I just have to make sure that 6 doesn't cause a 0 in my denominator. No problems here, no problems here. 6 is my answer, okay? Now it's possible you could have multiple answers. You could have gotten a quadratic left over, okay? You have to check all your answers. It's possible that when I got the 6, it caused a problem and I had no solution here, okay? Anything's possible. You just have to make sure that you get your least common denominator, that you check your answers to make sure it did not cause a problem in your denominators. Yes.